In the visual arts, color theory. A color theory is a body of practical guidance to color mixing and the visual effects of a specific color combination. There are also definitions of colors based on the color wheel: primary color, secondary color, and tertiary color. Although color theory principles first appeared in the writings of Leone Battista Alberti and the notebooks of Leonardo da Vinci, a tradition of color theory began in the 18th century, initially within a partisan controversy around Isaac Newton's theory of color and the nature of primary colors. From there it developed as an independent artistic tradition with only superficial reference to colorimetry and vision science. Color abstractions. The foundations of pre-20th century color theory were built around pure, or ideal colors, characterized by sensory experiences rather than attributes of the physical world. This has led to a number of inaccuracies in traditional color theory principles that are not always remedied in modern formulations. The most important problem has been a confusion between the behavior of light mixtures, called additive color, and the behavior of paint, ink, dye, or pigment mixtures, called subtractive color. This problem arises because the absorption of light by material substances follows different rules from the perception of light by the eye. A second problem has been the failure to describe the very important effects of strong luminance contrasts in the appearance of colors reflected from a surface as opposed to colors of light. Colors, such as browns or ochres, cannot appear in mixtures of light. Thus, a strong lightness contrast between a mid-valued yellow paint and a surrounding bright white makes the yellow appear to be green or brown, while a strong brightness contrast between a rainbow and the surrounding sky makes the yellow in a rainbow appear to be a fainter yellow, or white. A third problem has been the tendency to describe color effects holistically or categorically, for example as a contrast between yellow and blue, conceived as generic colors, when most color effects are due to contrasts on three relative attributes that define all colors: lightness, saturation, and hue. Thus, the visual impact of yellow versus blue hues in visual design depends on the relative lightness and saturation of the hues. These confusions are partly historical, and arose in scientific uncertainty about color perception that was not resolved until the late 19th century, when the artistic notions were already entrenched. However, they also arise from the attempt to describe the highly contextual and flexible behavior of color perception in terms of abstract color sensations that can be generated equivalently by any visual media. Many historical color theorists have assumed that three pure primary colors can mix all possible colors, and that any failure of specific paints or inks to match this ideal performance is due to the impurity or imperfection of the colorants. In reality, only imaginary primary colors used in colorimetry can mix or quantify all visible colors, but to do this, these imaginary primaries are defined as lying outside the range of visible colors, i.e., they cannot be seen. Any three real primary colors of light, paint, or ink can mix only a limited range of colors, called a gamut, which is always smaller than the full range of colors humans can perceive. Historical background. Color theory was originally formulated in terms of three primary or primitive colors: red, yellow and blue, because these colors were believed capable of mixing all other colors. This color mixing behavior had long been known to printers, dyers and painters, but these trades preferred pure pigments to primary color mixtures, because the mixtures were too dull. The RYB primary colors became the foundation of 18th century theories of color vision, as the fundamental sensory qualities that are blended in the perception of all physical colors and equally in the physical mixture of pigments or dyes. These theories were enhanced by 18th-century investigations of a variety of purely psychological color effects, in particular the contrast between complementary or opposing hues that are produced by color after images and in the contrasting shadows in colored light. These ideas and many personal color observations were summarized in two founding documents in color theory: The Theory of Colors by the German poet and government minister Johann Wolfgang von Goethe, and The Law of Simultaneous Color Contrast by the French industrial chemist Michel-Eugène Chevreul. Charles Hayter published a new practical treatise on the three primitive colors assumed as a perfect system of rudimentary information, in which he described how all colors could be obtained from just three. Subsequently, German and English scientists established in the late 19th century that color perception is best described in terms of a different set of primary colors: red, green and blue-violet, modeled through the additive mixture of three monochromatic lights. Subsequent research anchored these primary colors in the differing responses to light by three types of color receptors or cones in the retina. On this basis, the quantitative description of color mixture or colorimetry developed in the early 20th century, along with a series of increasingly sophisticated models of color space and color perception, such as the opponent process theory. Across the same period, industrial chemistry radically expanded the color range of light-fast synthetic pigments, allowing for substantially improved saturation in color mixtures of dyes, paints and inks. It also created the dyes and chemical processes necessary for color photography. As a result, three-color printing became aesthetically and economically feasible in mass-printed media, and the artist's color theory was adapted to primary colors most effective in inks or photographic dyes: cyan, magenta and yellow. These CMY primary colors were reconciled with the RGB primaries, and subtractive color mixing with additive color mixing, by defining the CMY primaries as substances that absorbed only one of the retinal primary colors. Cyan absorbs only red, magenta only green, and yellow only blue-violet. It is important to add that the CMYK, or process color printing, is meant as an economical way of producing a wide range of colors for printing, but is deficient in reproducing certain colors, notably orange, and slightly deficient in reproducing purples. A wider range of color can be obtained with the addition of other colors to the printing process, such as in Pantone's hexachrome printing ink system, among others. For much of the 19th century, artistic color theory either lagged behind scientific understanding or was augmented by science books written for the lay public, in particular Modern Chromatics by the American physicist Ogden Rood, and early color atlases developed by Albert Munsell and Wilhelm Ostwald. Major advances were made in the early 20th century by artists teaching or associated with the German Bauhaus, in particular Wassily Kandinsky, Johannes Itten, Faber Biran and Joseph Albers, whose writings mixed speculation with an empirical or demonstration-based study of color design principles. Current status: color theory has not developed an explicit explanation of how specific media affect color appearance. Colors have always been defined in the abstract, and whether the colors were inks or paints, oils or watercolors, transparencies or reflecting prints, computer displays or movie theaters, was not considered especially relevant. Joseph Albers investigated the effects of relative contrast and color saturation on the illusion of transparency, but this is an exception to the rule.